Hello, this is Shami Raza myself, and I'm going to perform this task for this Sparks Foundation. This is the task number one, and I'm going to apply a simple machine learning model, which is going to be supervised model, and I'm going to predict the score of students if the student is going to be studying for 9.25 hours per day. So for this task, I'm going to first of all import the libraries, which is pandas, numpy, and matplot in this case, which is going to be used for visualization. Then I'm going to import the data from the CSV file, and as we can see there is only two columns, so we are going to apply a simple regression model for this problem, as it is only two variable and we have scores as dependent variable because we are going to predict the scores using the hours column. So we are going to assign the values of hours and scores to x and y using the built-in function of values, and as we can see it is going to return us the numpy array. Now I'm going to determine the relationship between the hours and scores column, as we already know that whenever we are going to determine the relationship between the two variables, we have no better choice than using a scatter plot. So I'm going to do the same here, and I'm going to use our scatter plot. As you can see, we can observe that basically this is a linear graph and I have a linear pattern here. So that means that I'm going to apply the linear model, which is going to be the regression model on in this case. So I'm going to calculate the mean for this x and y, and which is going to be 5 and which is going to be 51 if we are going to round it off. So next we are going to import our machine learning model from scikit-learn, and then we are going to evaluate also the performance of that machine learning model. First of all, I'm going to import the linear model, which is going to be linear regression from linear model, and then I'm going to import the train test split from the scikit-learn model selection, because this is going to transform our data into the training and testing data, and it is also going to let us have the training and testing data into the 80-20%, 70-30%, whatever we have or whatever we had defined the size of the testing data. And then we are going to import the R2 square algorithm from the matrix, which is going to let us know if our predicted value is close to the actual value or not, and how our ML model is performing. So now I'm going to import these libraries, and then I'm going to split the data into 80 and 20%, as I have already defined the test size to 0.2, which means that I have 20% test size data and 80% training size data. So I'm going to execute it, and also I'm going to reshape it because we already know that our ML model is not going to accept simple 1D array, and we have to feed it the 2D array. So we have reshaped it, and as you can see we have a 2D array here. Now uh, I'm going to train our linear regression model. First of all, I have to create an object of our linear regression model, and I have created an object named reg, and this is our model, which is now trained. And now I'm going to predict the values of y using the test values of x. Now I'm going to predict the values, and this is how I have predicted the values, and also I have applied the R2 square prediction evaluation model algorithm on this, and it is telling me that its value is 0.94. So basically our R2 R square algorithm give us the values in points notation, and the closer our point value is going to be to the 1, then it's better. Like how much closer our points value are going to be to the 1 value, and that tells us basically how our model is performing. So basically it's 94% efficient, so this is more than enough for now. And now I'm going to visualize it using the scatter plot again, and we can see that this line is basically the our predicted values using the x values. So basically these blue circles are our actual value, and this red line is our predicted value using our machine learning model, which is not bad, which is pretty close. And now I'm going to see our data in our data frame and using pandas. So you can see we have predicted values, actual values, and hours. So upon applying the 1.5 hours, we have 20 actual value, and our model predicted 16.95, which is not bad, pretty good. And now again we have hours 3.2, and our actual value is 27, and our predicted value is close to 34, which is pretty much difference. But as you can see, this is how our model predicted. So we are going to predict now the actual task that we have been assigned on. We are assigned 9.25 hours per day. So we are going to predict this value. And as you can see, our model predicted that uh, the student is going to score 93.71 if he is going to be studying for 9.25 hours. So now I'm going to determine what is our mean absolute error. Mean absolute error basically tells us that the difference between our actual values and to the predicted value. Basically, this tells us what is the mean of all the predicted and actual values. So this determines, let us know that whether if the difference is high or low, or how our model performed, and that's all. So I have performed this task for this past foundation, and I request you to please evaluate it. Let me know how I performed, how I done, and also give me the evaluation. And I thank you for your time, and thank you very much. And you all guys have a nice day. Thank you. Bye.